Honor students, I'm sure you have really enjoyed having a day off this Friday, but that does mean that we have lost a teaching day. Good news for you is the particular subject we were going to cover today is a relatively easy one. So I trust that this lesson that you're going to work on almost independently is relatively comfortable for you. I will be collecting these 8 pages completed with work shown. I expect work to be done in pencil and then corrected in red pen. And you're going to turn this in on Tuesday. And this is going to be worth 10 points because it is now counting both as a classwork and a homework. So you must show your work in pencil and correct in red pen. This video is going to get you through a little bit of each page. I'll tell you when to work and when to pause. And then the answers are online when you're finished. Let's start with this page. One of the key things that you have to be able to do is to handle radicals. To handle radicals when you're dealing with the Pythagorean theorem. So most of this page you're going to do on your own. I'm simply going to get you set up for 3 problems. Let's start with the first one here. Here's a really important pattern. Root 5 times root 5, of course, is root 25. But that's perfect. So what you're going to put in that box is just a 5. Root 7 times root 7, of course, is root 49. But right here, just 7. So what the pattern I want you to see is any radical times itself is just the number on the inside without the radical. Now this one, I don't want you to do the in-between step. Root 11 times root 11, you have 5 seconds. Put the answer in. 5, 3, 2, 1. Okay, you should have known that that was 11. For these guys, where you have coefficients and inside radical, you do what outies and innies. Outies connect, innies connect. In this one, your outies, 5 times 5 is 25. Your innies, root 2 times root 2 is 2. Outies, innies, and then you multiply. So what goes in there is 50. I think you're beginning to see the pattern here. So pause the video, do the entire page, and then pull up the answers on your iPad and check this page. It is important you check this page before you move on because you have to be able to handle radicals for the rest of the lesson. Okay, you're now looking at this page here. So the next 2 pages, what you're going to do is you're going to identify your short side, your medium side, and your longest side. And you're going to plug it into this equation, short side squared plus medium side squared, and you're going to do a comparison to the longest side squared. And inside this box is going to go one of 3 symbols, equal to, greater than, or less than. So this first one, your short side would be 7 squared, plus your medium side, 13 squared. And then over here, you do 14 squared. Leave this blank. You solve. And as you solve, inside that blank space is either going to go an equal sign, greater than, or less than. You're going to do this for all page 2 and page 3. And your goal is to find a pattern after you do all of these, to find a pattern that answers these 3 questions. Do these 2 pages, then correct your work, and continue with the video. Pause the video and do these 2 pages. Okay, students. Ready. Take a look at this diagram here and this quick animation. This animation, in a very simplistic way, a very physical way, is showing you that the square of the short side plus the square of the other leg in a right triangle equals the square of the hypotenuse. You commonly know this as a squared plus b squared equals c squared. You've most likely used this several times. A squared plus b squared equals c squared. Now that you've seen me write this down, I want you to get a heads up about the way I teach geometry. You will never see that equation again. I will never use that particular equation. There's a reason why. A lot of students, at least in my experience, they get hung up on which one's A and which one's B, and it causes confusion. So I prefer what's called the descriptive version of the Pythagorean theorem, and this is the one I want you to use. You label your two legs, which of course are hinged to the right angle, and then the hypotenuse is the longest side opposite the right angle. And if you have two sides in a right triangle and you need a third side, what do? You use the Pythagorean theorem, but this is the version I want you to use. Leg squared plus leg squared equals hypo squared. This is called the descriptive version of the Pythagorean theorem. I want you to get in the habit of using that instead because it actually describes what you are doing. So right here, let's just do this one together really quick. First, you identify your legs, and I actually want you to write the word leg and leg. And then identify your hypo. I want you to actually write the equation out every single time. You're like, but this way, I learned it like 5 years ago in 5th grade or 6th grade or whenever you first encountered this. I don't care how long ago you first encountered the Pythagorean theorem. I still want you to write out that equation for every single problem. And you're going to circle plague signs. I circle the word leg. You physically circle what you are plugging into the leg. Physically circling is important. You circle, plug, and chug is my euphemism for do the work. Circle the word leg. Circle what you're plugging in. Circle hypo. Physically circle what you're plugging in. Now it's super important. I do not want you to simply sticking the 2 there because you are not squaring the root 3. You are squaring 2 root 3. So make sure you put parentheses around things like that, that you're squaring the entire expression there. You know that this is root 10 times root 10 plus x squared. And this exponents, you expand. Exponents, you expand. I don't want you doing that multiplication in your head, please. I want you to see what's called the expanded form of that exponent. Of course, this is just 10. Outies, innies. A common mistake I see in my standard classes, hopefully not in the honors class, but I'm just going to show you just to reinforce that, the students, they see that too, and then they do this. And then because it's a whole number, and you guys are all convinced that fractions are of the devil, you think you're right. But of course, that would be wrong, because this exponent isn't a physical 2. It is simply, of course, taking x and times in by itself. So the opposite of squaring is square rooting. The opposite of squaring is square rooting. So of course, our value for x is root 2. Now, if you have a radical as an answer, I expect you to simplify if possible. If 2 is prime, you're done. Cross this out. It's obviously incorrect. All right, the next 2 pages. You are here on an honor code. Why is it an honor code? Because you're working at home alone and there's no one looking over your shoulders, but I'm giving you these instructions for the next 2 pages. Okay, this page and the next one. I do not want you using calculators. I like you to do it longhand, so in all your work, you may use this perfect square table as reference. You got the perfect squares all the way to 30. I really want you to have the discipline not to use a calculator for these 2 pages. Go ahead, do the work. You're going to summarize your work right here. You can check your work if necessary, but I think it'll real quick, you will see what's pretty obvious that I want you to see there. Pause the video, do these 2 pages, and then restart. Welcome back. So this page and the next one, you're simply obviously using various forms of the Pythagorean theorem to come to some conclusions. This page, I want you to go ahead and plot those points, and then you're going to find the distance of all 3 of these. And when you find the distance form, I want you to just leave them under the radical sign. So all 3 of these will have radicals. I want you to leave them under the radical sign. You'll see why in about 5 minutes. Finish your work for the entire page. Then I want you to read this. There's some sort of computational work you're going to have to do here, and then summarize what you observe. Do this page in pencil, and then check your work. All right, last page. Last page is, again, using the Pythagorean theorem, but now you have to be able to visualize these in 3 dimensions. Here you have a cone in 3 dimensions, a cylinder, and, let me just clarify, a square-based rectangular prism. So both the front and the back are squares. Every edge that you see, these are parallel, and of course you have right angles at all the corners. So this last page is testing to see your ability to visualize right triangles in 3-dimensional space. Show all your work, work in pencil, then correct in red pen. I'll be collecting this page, all 8 pages, when you return on Tuesday.